All right, everybody. Welcome to the Defense and Management track. I'm Flo. I'm going to chair the track today and tomorrow. This is Andreas. He's going to be the co-chair. So if you have some organizational issues, just throw stuff at us and we will be coming back and we can solve issues sometimes. Then we also have technical staff right there. So if you have any questions, if something's too loud, if something's too noisy or whatever, you can also ask our technical staff that is around there. Kevin is sitting back there. Niklaus is closing the doors right now. So feel free to approach us if there are any problems or you have any issues. I will keep this introduction very, very short to not steal some time from the speakers. This is Pablo and Noel. They're going to talk about the cloud. We actually have a camera right here in front. And we asked the guys if they need the camera, because normally if you have hardware with you, then it's like, you put the hardware under the camera and you can stream it up there. And then they replied kind of like, it's about the cloud, so we probably don't have a camera showing
The
anything.
cloud is here.
The cloud's here, all right? They got the cloud with them, so stage is yours.
Thank you. Hi, good morning. Thank you for being here, and thanks, Trooper, for receiving us another year and allowing us to present our research. So I hope that you enjoy our presentation. Our usual disclaimer, let's keep it. Noel and Pablo, both of us work for Onapsis. We already have been presented, so let's go. Our agenda for today. First, I'll introduce Cloudfoundry for those that are not used to the term or to the technology. We will talk a little bit about SAP HANA and XS Advanced. That is the Cloudfoundry implementation that today we will be analyzing and showing our research, last year research audit. Pablo will present some bugs and vulnerabilities that we found, and we will close the presentation with some conclusions. So, have you ever heard about Cloudfoundry? Do you use it? Please raise your hands. Okay. What's Cloudfoundry? If you go to the documentation and check it, it says that it's a kind of software that you can use or you can deploy on-premise on your hardware or also in different cloud providers that allows you to run applications. It provides three important things, or the three most important things for me were abstraction, scalability, and simplicity of use. Abstraction, because it's a kind of a layer between the applications running in the cloud and the cloud provider, which abstracts its details. Scalability, as maybe the guys that you are using Cloudfoundry will know, Cloudfoundry is backed by big companies, and that depends on having applications running in the cloud, and they need to have a solid strategy for scale. And simplicity of use is a little bit tied with the abstraction, as developers don't have to worry about the specific details of each cloud vendor. But the most important thing for me when I was trying to understand what was Cloudfoundry was this. As every cloud provider has its own details, the good thing about Cloudfoundry is this, that it makes all the clouds kind of equal, and developers can forget about the specific details of AWS, Google Cloud, or the platform that they use. If we go and look at the specific details or the most important components, or at least the ones that we will be talking today, we have first the router, which is in charge of receiving requests to applications running in Cloudfoundry, but also requests for for user administrators that want to perform changes in the platform and route them through the specific component or the application, in case that is an end user accessing an application running in Cloudfoundry. Later, we have the user account and authentication, which, as the name implies, provides mostly authentication services for applications running in the cloud, but also authentication for administrators, again, trying to get access to perform tasks in the platform. We have the cloud controller. Pablo will be talking in detail about it, but for now on, we consider this the brain of the platform, in charge of the deployment of applications and keeping track of this idea of organization and spaces that is part of the Cloudfoundry platform. We will talk a little bit about that later too. And finally, the service brokers. As Cloudfoundry, it was designed to allow to running applications in the cloud, and those applications could need third-party services to properly run. For example, I don't know, database connection, file system storage, a secure storage, all kind of services that you can need as developers or the application could need are provided by service brokers. There are different Cloudfoundry implementations. There are like more than this one. For us, maybe these are the biggest vendors implementing in some way Cloudfoundry. And for us, the most important one, at least for this talk, is SAP, as we analyze and implement their implementation of Cloudfoundry, at least the on-premise implementation of Cloudfoundry. So before continue, I want just to do a quick refresh on the most kind of core topics or common topics on Cloudfoundry. As I explained, Cloudfoundry it's used to run applications in the cloud. Those applications almost always need services to run, which in this case are provided by service brokers. Service brokers provide service instances, which in the end are the ones providing services to the applications. The cloud controller has a different username and password combination to be able to connect to those services instances and perform different actions, such as creating new instances, deleting service instances that are not used anymore, performing changes if they are needed, and so on. Applications and services are like live in which is called spaces. That is an idea. This was designed to provide isolation. You can have in Cloudfoundry, you can have multiple organizations which at the same time hold the spaces. And so you can have an organization with multiple spaces running different applications, and applications running inside one space shouldn't be able to see things happening in another space and can't also use service instance part of other spaces. The same happens at the organization level. Different spaces are isolated from each other. Applications are able to use service instances through what's called binding, and the binding is performed by an action that is called service wiring. The service wiring process, what it does at the end is, at operating system level, it adds some environment variables to the application, and between some of them, the application will have the username and the password to connect to that service. Suppose that the application needs database access, it will have some variable, including the username and the password for the database or the secure storage or whatever service is using. As more or less what I already say about the spaces, but also spaces can have its own users. If you are a Cloudfoundry user in one space, it doesn't mean that you will be able to access all spaces, as you will have different permissions and authorizations in each space. You can think an example for that is developers in one space are not supposed to be able to modify maybe the production space. Privileges are grouped in a specific way called scope, and each component tends to have its own scope. Suppose that you are trying to build an administrator user for Cloudfoundry that it's in charge of the cloud controller. It will be great to have kind of a scope, a controller scope that has all the privileges and authorization required to manage and turn off, restart, or perform modifications over the controller. And that's the way that Cloudfoundry has these capabilities. Each component has its own scope, and it includes all the required authorizations to manage that component. At the same time, scopes are grouped into roles. So suppose if you want to have an administrator user for all the platform, you will have that, and the administrator role, which will have all the different scopes for each component. That's an example. There are others one, for example, the auditor one, which is able to read the data but not modify, as it could be used, for example, to auditing purposes. We will see that later, but we have admin roles, scope, auditor roles, and other roles as well. Okay, that's kind of a quick and really quick introduction about what Cloudfoundry is, but for us it's enough, as we will be analyzing now the SAP specific implementation details. But before going to that, I want just to mention some why it's important, or why we did that. We started analyzing the XS Advanced, which is the SAP specific implementation for Cloudfoundry, and you could ask, or could be a good question, why SAP decided to implement its own implementation of Cloudfoundry. Well, the thing is, in the cloud, in SAP provides cloud services, and in its cloud, they implemented a Cloudfoundry fully compatible platform. But the question is, what happens on premise if you have SAP HANA, which is a really important product for SAP that is specific. It's not specifically a database. It's more like a application development platform, which also includes a database and in-memory database. And the important component for our talk here is the XS Advanced. In the beginning, SAP HANA included what is called, with the data, or with SAP HANA, the application runtime server called XS Classic, which was kind of a web server, but also allowed developers to create applications. But that wasn't enough, or good enough for big companies trying to create cloud applications. So they decided to deprecate it and include the new XS Advanced, which is the on-premise version of Cloudfoundry. If you want to run SAP HANA on-premise in your hardware, in your own data center, you will be able to do so, but you will be using as Cloudfoundry implementation the XS Advanced. That is not fully, it's not a full implementation, but it's Cloudfoundry compatible. We will see in the next slide which components are still there, part of Cloudfoundry, and we will see that others that are in Cloudfoundry are not in SAP XS Advanced, but and the other way around as well. We will have some components only specific for the XS Advanced. The overall idea of this is, if you developed an application on premise on the XS Advanced, you will be able to deploy it on the cloud without having to do any modification. That's the idea, I think, for SAP. You develop on premise, and once you are ready for the cloud, or you need to go to the cloud to be able to scale quickly, or whatever reason, you will be able to do so, as the applications are, as the implementations are compatible. Here we have both implementations. If we think in Cloudfoundry router, we will see that we have the application router in SAP XS Advanced, which is more or less the same and have the same purpose. Regarding the user account and authentication of Cloudfoundry, we have the same in SAP HANA, in the XS Advanced, sorry. In this case, HANA database is being used as identity provider, which means that all user accounts will be database accounts in some way. This is default, but it's not the only identity provider that you could have, but it's the default one. If we continue looking at XS Advanced, we have some block here, which is called the XS Advanced Runtime Platform, which for us, at least, has its counterpart in Cloudfoundry with different blocks or services. The blob store and application executing engine, the service brokers, and the cloud controller. All those parts of Cloudfoundry, for us at least, are in the XS Advanced Runtime platform. More or less, as you can see, is the same. There are some things that are specific for one platform and other for the other one, but in general terms, is kind of the same, as you can see. Regarding network connection, if you are going to pen test, or if you want to know how to connect, or how Cloudfoundry is used, the XS Advanced is used, we have in green which is called public ports, reachable from the outside, beginning with port 3XS32, which is used by applications to connect to the user account and authentication service to ask for credentials. Remember that I didn't say that, but these components could be running in different hosts. I mean, in this case, you can think, okay, all runs in the same host, but the idea is that you can separate all components and more or less make it run in different hosts to have more computation power. Or okay. So I was speaking about the applications connecting to the user and account and authentication. They connect in port 3XS32 and ask for authentication services. Administrators trying to perform administrative tasks over the platform using the client, the command line client, connect to port 3XS30, which is the controller, kind of the brain of XS Advanced. And end users trying to connect to the deployed applications will use port 51000 to 51500. XS Advanced also uses internal ports to perform different kind of communications in the ports that we have here. For us, the most important ones are the public ports.
Thank you. So first of all, do you hear me? Yes? First of all, I'm going to activate something that I forgot. That is something related with the live demos we have. Okay, let's go back. So let's start to talk about a little bit about our research. Okay, so the first thing this is a graph of XSA. So as you can see there are a lot of components that now already mentioned, that the router, the database, whatever, but in the middle is the controller. Okay. So when we start this research, we say, okay, which is the component that we should start doing the research or attacking? We decided controller because, as now mentioned a couple of times, it's like the brain of the environment. It's like the captain of the team. It's like the Nahuels of troopers. Okay. So it's the one in charge of managing the spaces, the organizations. It's the one that will provide all the different services in order to administrate. For example, if you are an administrator of the environment or if you are a developer, you will start interacting with the controller in order to push applications, to delete them, to develop, to create new services, to create new service brokers. All that kind of interaction is being done by the controller. How the controller exposes these, let's say, services? By using APIs, RESTful APIs. In terms of connections, for example, having the graph, the controller receives all the HTTPS requests from the outside world, yes, but where basically there are the APIs exposed. Then there is a connection with the internal hosts that are the execution agents where the applications are currently running. This communication is not important for our research, but just to mention, it's very protected. They have a system PKI that are mutual authenticated, so it's not important for us right now. Then, as any other component, they need a connection to the database because they have to store data persistently. So we're going to talk a little bit about that. And finally, you have the connection to the service brokers, which is basically done by using the service broker API, which is something open source, and you can see all the different services that each service broker should expose. And all these service brokers are always managed by the controller. So about the exposed APIs, how we can interact, or how administrator, or auditors, or whatever speak with this controller is by using the exposed APIs. You can force your own HTTP raw requests, but HTTP gives you the client, the command line client, which is called XS. Those familiar with Cloudfoundry will notice this more or less the same as the CF. And with this client, you basically, it's like a command line interface, but it's more like user-friendly. But below that, it's just using the same APIs that the controller exposes. So when we start this research, we say, okay, the controller is exposing a lot of APIs, let's say between 25 and 30 APIs. Each API has between 5 and, 20 maybe services. So that means there are hundreds of endpoints, okay? So if we try to do it manually, the analysis will take a long time. We should do it something different. The first thing we realize is that the controller is shipped as a jar file. So the compiling the source code and getting some kind of accurate source code is pretty easy. So we decided to go that way. And what we did basically was create a parser that will analyze all the code that was implementing these APIs, okay, and generate another structure with all the endpoints, okay? And for each endpoint, we have the headers that each endpoint needs, the parameters, the kind of the type of the parameters, and the full path, and more things, more data that afterwards could be like further used for building micro applications that will do some kind of testing, like fuzzing or whatever we want. That tool is gonna be in our GitHub, so I'm not sure if it's gonna be able you to use it because it was really forced for our research, but maybe it can help you in doing some research also. So what about the protections that the Cloudfoundry or XSA has? We already mentioned some of them, like for example, users in space are not necessarily users of other spaces. The same happens with organizations. That's what we like to call administrative level. Then also the spaces has a protection in kind of development layer. This means that applications running in one space cannot interact with applications in other spaces as well. Then they have a very cool one that is that each space will run with a different OS user. And more or less in the final part of the talk, we are gonna come back here because it worked basically. It was very good. Afterwards, you have what is the authorizations per component that I know we already told you, and we're going to talk specifically about the one that is by organizations and by spaces. And finally, there is also a kind of isolation in the application layer, because each application, when you bind it to a service, it generates new credentials, and that credentials should not be like accessible from other applications, even in the same space. And for sure, they have more, but we are going to speak a little bit about these ones in the future. Talking specifically about the controller has, in terms of authorizations at the organization level and in space level, they have two different roles. The first one is you can be a manager, which means that basically you can do whatever you want. At the organization level, for example, you will be able to create spaces, to delete spaces. If you're an auditor, you just can see that resources, view them, and maybe audit them. In the space level, they have an extra authorization that is called the developer. That is basically, he has some kind of privileges to push and create application, restage started, and more actions. But from the documentation, we get this quote that says that auditors can view space and organizations' resources, but they should not be able to see credentials. So here we have our first demo. They are all live. I hope it works. So
demo bots will be with us. No, don't worry.
Okay. No.
No.
No. Sorry. We have the backup video. So first of all, the attacker will log in as an auditor to the environment. And this screen is basically showing that the amount of the authorizations that the user has is just an auditor of the space. So it should not be able to read the credentials of the applications, for example. We are capturing the traffic that is going through the client. And in some moment, when you are just listing the applications of the spaces, it's sending an HTTP request to a particular API. So we are going to copy that request with the same bidder token. This is using OAuth. So we have to authenticate. The authentication is the authentication that represents the auditor. So we still are auditors there. And what is going to happen is that up to now, we just resend the same HTTP request. And as you can see here, the attacker will try to look for HDI user there is a field that should appear if you have credentials over there, and it will not appear anything. But if you just change a parameter that maybe from the box you didn't read, but it says no service credentials, it was set to true by default. If you change it to false, guess what happened? All the credentials will be there for you. And these kind of credentials are basically the credentials that the applications use to connect to the database, for example, meaning that an auditor, which should not be able to access the data, will be able to access the business data of the applications. Thanks. So what happened basically, yes, that with the space least privileged user, we were able to basically get the credentials of applications that must hold business data. This is a real patch. So if you want more data about the patch, you can go to the subsecurity node or to the CVE to learn about the vulnerability. So coming back to this part, now we are going to focus a little bit on the connection to the DB. Every component, more or less, like for example, the UAA or the controller, of course, and the applications need connection to the database because they have to store data persistently. Of course, they have their own users at the database layer, and the controller uses one that is called sysaccess runtime. Just save the name. And this guy is very powerful at the database layer because he has 3 different authorizations that maybe for you are not familiar, but basically catalog read means that they have access to view all the system views, which means that he can read all the configurations of the ACP system, the HANA database, and a lot of technical data. The other thing is that he is able to modify all the configuration files. This is the second authorization. And finally, the third one is that he can access to all the data that is stored in the user secure store, which is like there is some private data. Usually there are credentials and some kind of data stored over there. So here comes our first, at least from our point of view, nice finding. We found that there was one endpoint of those, that I told you there were a lot of services and a lot of APIs. We found one parameter in one API, in one web service, of course, that was not currently synthesizing that parameter that was afterwards used in a SQL statement. So we say, okay, we almost win. The problem was that this parameter, the input that we give to the endpoint was being used in 2 different statements at the same time. Meaning that if we want to exfiltrate data, we couldn't because if we try to match, if we were using a union, for example, to get data, if we try to match the types of the fields, we are going to break the following statement. And if we try to match the second statement, we are broken the first one. So it was difficult to exploit it, but basically, using some very well-known technique, we started doing an exploit of a blind SQL injection, okay? And basically using an error-based, we could achieve, anyways, some exfiltration. And this is our second demo. I guess this, yes, should work. Okay, so on this pane, what you are doing basically is, without any kind of authentication, just getting information from a particular table that so in
Python 3? Python 3? On Python.
Why is it working?
Maybe you don't have connection. I don't know.
Okay. Obviously, they don't work. Sorry for this. So, again, on this pane, what we are doing basically is executing the SQL injection without any kind of authentication and trying to get a field that is called broker password. And in this field, in this pane, we are getting the broker user. So these password credentials were written in plain text in some table that with the current user that we are executing these SQL statements was readable. So here is the exploit is working. Due to this blind SQL injection error base, we have to guess like byte by byte the name of the field. For example, if you are looking for a field, we have to first take the length of that field and then guess byte by byte how we can in order to get the full field. On the left side, what we are executing is basically a query that will say us, well, will return us the name of the user that is currently executing these statements. Okay? So now we can move forward a little bit. After some processing here, what we can get is all the values that were found related with the broker user and broker password. I mean, basically cleaning all this output that is a little bit noisy. And these are the credentials that were getting from the table. Just for the sake of this demo, we already know which is the credentials, but right now we are going to test it in a currently implementation of a broker. Okay? At this moment, this query already executed, and we can know here that we are running at the CSXS runtime, which is the owner of the whole schema in XSA.
Yeah, just to do a quick recap, we were able to find a blind SQL injection in one API part of the controller. So that's it looks that we were really lucky to find that, because also it was unauthenticated. It was kind of most of the APIs were authenticated, and luckily we found this one which didn't require credits and also was vulnerable to a SQL injection. So it was kind of powerful bug.
So afterwards, what the attacker is going to do is it's going to try all the credentials against all the brokers that are running that space. At this moment, we already know which broker is. So we are going to show you just that we are going to point to that broker, to the application that is currently running the broker, the service broker, and it's going to ask for credentials. Of course, we don't have the credentials, but leveraging what we did with SQLi,
we knew that API should exist, as the brokers had this common API, and all of them have to use it. I mean, it is so the catalog thing is just a common API that brokers must implement.
So what we did here was basically without any kind of authentication, get the necessary credentials to be or to pretend to be the service brokers. With the service brokers, this means that we can do all the method that the Open Brokers API exposes, which we are going to mention them in a couple of minutes. But what happened, it was basically one error in one parameter of one web endpoint of one API in the controller, which opened a big hole. Again, this was already patched, so if you want more information about that, you can go. A funny thing, at least from our point of view, is that the CSS of this vulnerability was 0.503. And I'm going to go back to this in a minute. So what happened about the protections? Well, the protections, most of the protections that we mentioned at the controller level, they can be circumvented because basically we are like in a higher level, okay? So space isolation for us is not important because we are in the controller, so we can see all the spaces, we can see all the information in all the spaces. However, the business data that are holding into the applications that are stored there, we couldn't access it. So that was a good point. Anyways, the technical data that we can get, as you may see before, as you may saw, is pretty important. So now we have the SQL injection. What we can do in terms of post-exploitation. These are some of the things and the data and the tables that can be accessed with this user, with the SSXS runtime. The most important one is this one. That was the one showing the demo. In this table, what you have is a lot of information regarding IDs of the spaces, of the droplets, of the services and more information that is more like technical information and it's not very business one and it's not like very critical. Maybe the guys that are more familiar with Cloudfoundry know the VCAP service. VCAP services is one environment variable that usually has credentials. We are not able to get them because that one are in the secure store, so we cannot access them. I'm gonna go back to that because supposedly the users this extra time have access to this user secure store, but due to we are injecting in an SQL statement, we cannot see the data inside the secure store.
Yeah, we could only do selects and not call store procedures, which was what we needed to access the secure storage. But we controlled the select, but we couldn't execute the store procedure to access the secure storage.
And also there were the password in plain text, as for example the service broker showing the demo. So what kind of things we can do without credentials that we already log in, and once we log in, well, what actions we can make? Well, basically, we can create, we can delete, we can bind, unbind, spawn new services, modify the service that already exists. All the services that were basically created with this service broker are owned by us, okay? We can do whatever we want with that. This means that basically, if we got the credentials of a service broker, that is, I don't know, the accessing for the database, for example, we can broke all the accesses from the applications, meaning that the application will not run any longer. However, this was not the best part, the most interesting part of the post-implementation part.
Now, before going to the last demo, I want just to explain one last concept, a little bit SAP related, which is the idea of the landscape directory. You can think on the SAP landscape directory as an address book where all the systems that your company have must in some way register and send their information. The XS Advanced is not it has to do it as well, and to do that, it includes an authenticated API, which is used to exactly do that. Say, okay, I'm the XS Advanced, I'm running on these hosts, and this is my information system landscape directory. Please update it. Only a really high privileged user can use this API to perform this action. But we found that the attacker, using the SQL injection that we previously shown, was able to obtain the credentials. And the credentials that he can obtain are valid to perform this action. So the attacker can send information to the SLD. The data that the attacker is controlling or sending to the SLD is sent as XML, and you can imagine what is coming. External entities were available for the attacker to use it. So you can imagine what we did or what the attacker can do, but it wasn't so easy. As the data, it wasn't sent back to the attacker, it was sent to the SLD. And sadly, the HTTP protocol wasn't implemented by the XML library that was used in the XS Advanced. So common tricks to abuse external entities didn't work. So we decided again to call our superhero. Pablo will show the demo.
There's only one.
1 on 3 will be.
So on the top part, we can think that there is the attacker. You see there? Is the attacker screen. On the lower part, it could be it is a top command running in the server machine. So what we are gonna do first of all is due to we have access to perform XXC, we can do a denial of service. So the attacker can provide, for example, how many processes they have to spawn. And you will see in the top that the applications start like increasing the CPU at 100%, 100%, 100%, the amount of processes we want to spawn. Even if we kill them from the client point of view, they will still run in the server. So this means that it's a matter of time until the server goes down. But also, we were able to get files from the file system. And let's hope it works. Yes. So again, thanks for that. So what happened basically was that the XML library that was being used by the system was not satisfying external entities, meaning that we could read files and perform denial of service. Why we couldn't, I mean, whenever you have an external entity, you can do at least 4 things. The 2 we did, and also maybe server-side request forgeries and port scanning. We couldn't do that because we couldn't exploit the part that the HTTP protocol was not implementing the library, and that was almost impossible, at least for us, to find a way to circumvent that kind of protection. One last thing is that all these, the files that we can read are written by the SIDM user, which is the administrator of the SAP system. So it's the most powerful, let's say, between quotes, user in that system. One important thing here is that, so we achieved to jump from an application that was running in the cloud directly to the operating system layer, jumping all the different layers that are in the middle.
And also, you have to think on that applications running in Cloudfoundry shouldn't have access to the real operating system file system. So for us, it's something that we want to stress, as commonly applications don't have that they can do that kind of things.
Again, this was patch. We didn't get more details because the patch was released 1 week ago. So we are trying to cover some things. What we can do, what files we can retrieve? Okay, we can retrieve files that are, for example, logs. We can retrieve files that are configuration files from the servers, from the UUA, and more data. But basically, what we couldn't achieve is to try to steal the business data of the applications. And that's why I told you that the space isolation at the OS level worked very well. Because every application is running in one space. That space is running with a particular OS user. And the files that are related to that application, or basically to that space, are protected with the flag 700. So only that user is able to read them. So we couldn't make it. So just recapping the different attacks. Basically, an unauthenticated attacker is able to execute an SQL injection, get the credentials, get some credentials that are stolen, okay, from the database, and finally perform, for example, denial of service of the system. Or basically doing the same with the same credentials, it's able to start reading files from the operating system layer. So, conclusions. First of all, okay, in this scenario, we use 2 different blinds exploits. So sometimes blind, I think, are like overlooked. So this is a way to confirm that they shouldn't be overlooked. Just that. Talking about the cloud, cloud is complex, it's huge. You have a lot of components to understand, and therefore it's very difficult to secure it. I think Rodrigo mentioned something in the keynote that complexity can increase the risk of doing something bad or introducing problems. So this is more in the same way. Also, the most important attack was being possible, just attacking one parameter from one API in one service method. This means that a little hole opened a big gap in the Cloudfoundry environment at this time. And lastly, the CVSS sometimes can obscure, I guess, at least from our point of view, the real impact of the vulnerability, because as I tried to mention before, the SQL injection was just at 5.3, and then that with another vulnerability that was, I think, 6.5 or something like that. I don't remember yet. It finally have something like, I think it's 10 or 90 or 9, something like that. But only like chaining them. Separately, they maybe not are very critical, but once you chain it, you can accomplish something that is a little bit more critical. In terms of our research, we found other vulnerabilities. We thought that these ones are the most cool ones to show, at least. And anyways, we still have to do a lot of work. We have to analyze other components because we should focus on the controller. There are much other components that are also important. The communications between the controller and the internal things, maybe something that is implemented there can be abused also. And of course, the application implementation. So we can there are a lot of applications that are shipped by default, so we can start analyze them and try to figure out if we can exploit one of them and afterwards do something inside the environment itself. So guys, I hope you enjoy our presentation, and this is everything for us. Thank you.
Thank you very much for your talk. I think that we saw that there were some really common problems that has been made in the implementation, but you did a very good job exploiting that, so that was not that easy as far as I understand that. What is your general view of the security job they did with the Cloudfoundry implementation? Is it, do you have a good feeling with the security implementation or not?
I would say that yes, that it took a great effort from our side to being able to exploit these kind of things. And in our experience, looking at the Cloudfoundry for the last, I don't know, 6 months or 4 months, something like that, it was a hard task to find some vulnerabilities that in the end we were able to exploit, lucky us. But in general, it was good. Yeah.
Also, one thing is that as it's complex, sometimes it's also complex to exploit it in a way that you have to understand a lot of things, and understanding that kind of things in order to exploit or to get more useful exploits is also complicated. Yeah. So it's like in order to exploit it, you have to understand all the environment, and that part is also difficult. But yeah, yes, I agree with Nawal that it's pretty good.
Yeah, also, maybe someone here knows that for sure more than us about Cloudfoundry, and it says these bugs, they probably one could say, hey, having that rights or that level of access, you can do this other thing that we didn't see as we started doing research over Cloudfoundry, understanding what was that just like 6 months ago. And I mean, we are not Cloudfoundry experts nor cloud experts, so maybe with the same kind of bugs, there is much more to do that we still don't know.
Yeah, thank you. More questions?
If you have an idea what else we can do, just approach us.
Did you have full access to the documentation and also the documentation of this concrete implementation for this test?
Yes. At least what's public anyone can get regarding the XS Advanced and Cloudfoundry.